Hello, everybody. This is Hazem Aboros with Crosslake, and we will start in just a minute. Okay, we'll go ahead and start. So welcome, everyone, and thank you for joining the Crosslake webinar series. Today, our topic is architecture technical debt. And, this is probably, this topic is discussed in every meeting, whether you're an investor, a CTO, development, or QA manager. So it's a popular topic. Technical debt is a reality. It's often challenging, for many companies, anyone who's doing software. And it's not just about how it's managed, but it's also about the ability to maintain the right balance, and addressing technical debt versus investing in net new functionality. So today, my colleague Wayne will discuss various approaches to how technical debt can be managed with real life examples and course corrections when it becomes problematic, especially. A few housekeeping items just before we get started. The slides you're about to see can easily be downloaded, and they are available in the handout window in the webinar. We will also follow up with a direct download link as well as a recording within 24 hours or so after the webinar concludes. Finally, during the webinar, please feel free to ask any questions. They will pop up for us in the questions window, and we will try and address these in as real time of a fashion as possible to get your questions answered. So now I'll introduce our speaker, Wayne. Our speaker, Wayne Filin-Matthews, is former global head of architecture at HSBC, and Wayne today is the architecture practice director at Crosslake. He has a wealth of knowledge on enterprise architecture and transformations. Again, thank you everyone for joining, and without further ado, I will hand over to Wayne.
Thank you, Hazem. Appreciate the introductions. Welcome everybody to the webinar on architectural technical debt. Just a little brief background in regards to my my history. So as Hazem said, for the last couple of years, I've been the head of digital architecture for HSBC globally, covering their new digital functionality across their 126 markets. Prior to that, I spent some time at Accenture and then 10 years at Microsoft as the architect role owner within Microsoft, with the last couple of years focused on artificial intelligence and machine learning as acting engineering interface for the office of the CTO. Been in the industry about 30 years. I'm a distinguished architect with the Open Group, so I sit on the Open Group OpenCA level boards, as well as being a fellow with the British Computer Society, sitting on their boards for CITP Chartered IT Professional status as well. Thank you for taking the time out this morning, this afternoon, depending on where you're located, to talk about this topic area specifically. It's an area of interest that I sort of picked up probably about 7 or 8 years ago. Technical debt's always been persistent in a lot of the organizations that I've either consulted for or worked for. And I'm currently doing a PhD on this particular topic area, because for me personally, it's one of those things, no matter what organization that you're working for or with, and it doesn't really matter the size of the organization, whether it's small to medium-sized businesses or whether it's large enterprises. Technical debt and some of the manageability of technical debt is really a challenge for most organizations. And we're going to talk a little bit around commonality and consistency of language in terms of what technical debt and what technical debt isn't, and a couple of sort of areas around the manageability, so best and current proven practice around the manageability of technical debt and where it occurs. So again, thanks for joining this morning. A little bit of what we're going to talk about. We're going to look at business and technology views around identification of technical debt. So what does technical debt actually mean? Is there such a thing as good technical debt versus bad technical debt? We're going to clarify the difference between something called the deviation expense versus technical debt that is traditionally talked about, specifically with a lot of customers that I've worked with and for over the last decade. And we're also going to sort of dispel some myths around complexity versus debt, and often the confusion between the two. So hopefully by the end of the webinar, if you're unfamiliar to this topic area, which I'm sure most of you will be familiar in terms of other conversations in your own organizations, is hopefully we can capture a few useful pieces of information that you can take back into those considerations for your own organization as well. We're going to look at capturing and managing technical debt, prioritization, how to prioritize technical debt, and just some business guidance on technical debt management, the technology considerations that I mentioned, and best and current proven practices. It's important not just to call them best practices, but those practices that we see within Crosslake that have proven the sort of test of time more than anything else. For each topic we'll look at, we will review some questions, so please feel free to ask questions. Hazem kindly going to moderate that for me, and I'll try to answer those to my best of my ability. We'll look for some of the good signs, red flags in terms of where technical debt may be incurring, and we'll keep things at a high level, but depending on your questions and the depth that you want to go into, more than happy to dive a little bit deeper as well. We normally have a mixed audience on these webinars, so we want to make sure that it's useful and articulated in a level that makes it useful to you post the webinar as well. So that's the topic area, and that's what we're going to sort of cover. A little bit about Crosslake. Crosslake really for me is one of the sort of best technology consulting organizations that I've come across and have been working with for a while now, just purely just because of the seniority of the individuals. You know, it has a lot of individuals that have failed fast, and a lot of that experience is brought into some of their consultancy services. You know, we are a global organization, focused in terms of our head offices in the USA, in North America, as well as in Europe, and we tend to work on sort of various projects, everything from technical due diligence to cost and complexity management of an organization moving to cloud. So it's broad and deep, with a lot of senior individuals that have failed fast and learned quickly from that failure, bringing that experience to the table in terms of topic areas such as technical debt that we're going to talk about specifically today. So architecture debt, the best analogy I ever saw specifically, and some of the considerations, that architectural debt and the trade-offs that architects and architecture, and again we're going to focus from an architectural perspective but cover the sort of broad landscape of stakeholders that need to consider technical debt, will have increased impacts and consequences for the ability of organizations to exploit the technology investments into the future. Industry commentators, Gartner, McKinsey, Boston Consulting Group, and various others estimate IT debt to be currently around $500 billion, meaning that architecture debt could be staggeringly higher. And my own personal experience in the roles that I've done is there's really two reflection points. One is technical debt is either captured and that's in a good organization and it's well understood, but very rarely is the management of the technical debt in terms of the framework applied as people go through the full architectural life cycle. So the concept of software and architecture debt has been around, for a number of years. It's not a new concept, but some of the new technology trends, cloud, microservices, etc., have forced both the discipline and the role of the architect in architecture to examine how technical debt will impact the life cycle of those architectures and their associated delivery into the future. The reason that I wanted to call this particular point out specifically is a lot of the time the balance between the science and art of architecture, as in the artful side of obviously creating solutions and leveraging best and current proven practice around modern techniques for creating architecture. Sometimes the business consideration and the technical debt consideration is often overlooked, not considered, or the political landscape of an organization restricts from a budgeting prioritization perspective on how to address that technical debt as they go through the life cycle of the architecture. So it doesn't really matter if you're in an organization that is traditionally waterfall and you're capturing requirements up front, or whether you're doing scaled agile development in a Scrum team. The considerations and framework from an architectural perspective are still exactly the same. They don't really change. What does change is just the need really for those that are sort of doing modern techniques for technical debt management to think about automated ways of predicting where technical debt may arise, and then subsequently providing the framework that then feeds back in to the business decision making, such as PI planning and working with the product managers and product teams in a scaled agile sort of framework. So again, not a new concept, but some of the changes that we see around methodology and approaches to creating our architectures are driving some different considerations, specifically around how do you automate the ability to manage technical debt more efficiently within an organization. As I just mentioned, the best analogy that I've seen to sort of really explain what technical debt is in a nutshell, but also introduce you to the term of deviation expense, which is slightly different when it comes to technical debt. So the example that we give here is if you're building a freeway or motorway or any road, then what tends to happen is during the construction of that road, various things tend to happen. So if we need to extend a lane, for example, we're going to have multiple stakeholders involved. We're going to have to, maybe close part of the road off. We're going to have to basically put signals in to slow people down, to make sure that the workforce is safe. At the same time, what we're trying to do is obviously minimize the time to obviously build the extension to the road. And you can reflect back on how this works in a software development life cycle, where we've got pressure from the business to add new features. At the same time, we want to make sure that the non-functional or quality attributes of the system are safe and maintained, so we don't lose the quality of the architectures that we create. And at the same time, just keep the traffic flowing. So these are all the sort of things that are happening simultaneously and in parallel, which becomes tricky in regards to obviously, first of all, identifying where the expense is going to come in. So we've added an extension in the analogy given here. The architectural debt consideration is is different to the deviation expense. So the deviation expense is really the cost to get the new features out in a timely, safe fashion as part of creating the extension to this particular freeway. So the difference between the deviation expense is deviation expense management is one of those first things that you have to consider when it comes to technical debt. Is if you're, for example, creating a new platform, and to enable that new platform, you may not have all the pieces together to actually deliver the strategic architecture, the long-term architecture on day one for minimal viable product. So you may incur some deviation expense, such as you may have to put a tactical solution in place just to get the things moving, to get that road system up to where it needs to be in terms of its design. And these are the sort of two main differences between the deviation expense and what is often referred to as technical debt. The deviation expense is not necessarily a bad thing, and is more often than not needed to obviously keep the architecture, the software architecture, moving in the direction it needs to go. But a lot of organizations really capture technical debt way down the road when the debt's already been incurred. And then at that point, it becomes difficult to go back and have a business conversation to think about repayment of that technical debt. So specifically calling out the deviation expense up front and having that at the forefront in the mindset of the architectural function helps you to plan accordingly the expenses that are going to be incurred, that ultimately allow you to manage the repayment of the deviation expense once the strategic technical debt platform is in place. So this was the sort of the best analogy I could give to you in regards to what technical debt is versus what deviation expense should be, but also should be the first thing that we think about in terms of capturing the considerations of the long-term technical debt that an organization may incur. More often than not, architecture complexity is really deemed as architecture debt, and to be honest with you, complexity can add to the levels of architecture debt that we're going to talk about in a moment. But the point of this slide is not to confuse architecture complexity with architecture debt. I've seen many architectures that are complex from an interoperability perspective. They've been complex in terms of just the size of the architectures that are created. Some have been tightly coupled, as in they're not modularized, etc., etc. The key thing is complexity is not necessarily architectural debt. I've seen a lot of organizations that have complex architectures but follow a systematic, methodical approach to architectural debt, technical debt management, that whilst they're complex, they have low levels of debt, and that it actually helps them from a velocity perspective to move things forward. The other thing to call out just at this point in terms of just some of the consistency of language, we should always refer to technical debt in two ways. Technical debt can be a good thing, and we'll talk a little bit more about that in a moment. But it's really the unmanaged technical debt that ends up coming back and sort of being that pain point for organizations and architectural teams that are trying to move an organization to the latest modernized approaches to architecture. And again, so it's you know, the three things to call out are deviation expense is a consideration for early on, making sure that we understand and capture the deviation expense if we're not moving to a strategic platform. That when we talk about architectural debt, it's different to deviation expense. And ultimately, when we talk about the architecture debt that needs to be repaid, we should always refer to it as unmanaged technical debt, because if we lump them all together under this broad heading of technical debt, then normally it's very difficult to convey the message to the relevant stakeholders. It makes it difficult to understand the interdependencies of where technical debt is slowing down the business to exploit technology investments that are being made. And it also basically makes it really difficult to obviously budget accordingly in the budget life cycle to understand where you need to focus the budget for any given fiscal period or any given sprint as part of PI planning in Scaled Agile, where to focus some of that monetary investment. So again, just some consistency of language, which helps us when we're articulating and having the conversations with organizations, actually helps you to steer and influence the relevant conversations that need to take place. Debt composition is made up of a number of things, and again, it's important, based on my experience and based on the organizations that I've worked, is that they don't tend to do this. What really happens today is we have this overarching umbrella term, technical debt, and like I mentioned previously, a good organization will at least capture technical debt. A sort of fantastic organization will have a framework in place to consider what technical debt looks like, both from a technical perspective, but also from a quality perspective, but also these other things that are often not broken down into smaller chunks, into smaller elements that can be tackled independently, rather than trying to tackle this big monolith of an item called technical debt. Design debt is part of the consideration. Workforce debt, again, you'll often see organizations throwing people at problems rather than actually understanding where the workforce debt resides, and that could be anything from utilization of the workforce to skill set and capability. When we look at management, again, the same as the workforce, the management layer, how effective is the management layer from a technical debt perspective? Are they thinking about technical debt? Are they proportioning budget to repay unmanaged technical debt? So again, just some additional considerations. Platform debt. A lot of the organizations I've worked for over the last 30 years, I think one of the biggest problems that I still see and face today, which is the reliance upon the monolith, where platforms have grown. They've decided, well, okay, we have a platform, we're going to roll out some features on day one, and great, that's moved us forward. And then on day two, well, we want some new features, so we're going to create this change and adoption management program, and we're going to create a new platform. And then a lot of organizations, without obviously giving the names of those organizations, have ended up with 5, 6, 7 platforms. And they've linked those platforms together because there's been an interdependency requirement, just because of the feature functions that are required, without thinking about how to retire the platforms that are in place today. And a lot of organizations, and this is why this particular pictorial is shown here, is platform is the tent, and then some new project comes along, and a new CIO comes on board and requests some new features. We need to increase velocity, we need to the business drivers behind why we need to do another evolution of the architecture, and the entropy seems to then come in without considering technical debt. So we ultimately end up with this glorious house, but really the cost of and complexity of managing that large household in the example given here actually is slowing down the ability to be innovative. And again, even when we introduce new modern approaches and new modern platforms such as cloud, without considering the framework of technical debt early on, is all that ends up happening is, yes, you get the benefits of the quality uplifts of cloud and the cost reduction in terms of pay per use, but what you end up with is a significant cost overhead when it comes to even organizations that are doing modern approaches to architecture, when it comes to actually managing the cost where they've got interdependencies around the platform. So we'll touch upon this a little bit more as we go through. Experience again ties into workforce and management. So experience debt, if you've got key people that aren't documenting and sharing via communities and really considering tacit and explicit knowledge sharing within an organization, then it's another form of technical and quality debt that adds a significant amount of risk to an organization, because again, it's often overlooked, and not knowing how to manage the experience of an individual or team of individuals can add significant risk to an organization as well. And then finally, documentation, and you'll hear terms like documentation as code, and you'll just really documentation a lot of the time is really the ability to make decisions based on good documentation, whether it's as documentation as code, or whether it's in traditional stored format on a Confluence site or another internal repository. Then it adds to a level of risk and technical debt that is often overlooked, because unless you have good documentation, it makes it very difficult to understand where the priority areas to remediate the unmanaged technical debt components comes in. So all of these together is really the shape of architectural debt, and specifically the focused area of how to manage unmanaged technical debt within an organization. A couple of things around, obviously, the elements that are driving some of the new considerations around technical debt. So big data or small data and business intelligence are driving new considerations for technical debt. Cloud and infrastructure, obviously, if you're not managing assets appropriately in the cloud, then you end up with significant debt and significant risk around things such as security and vulnerability. Mobility and devices are also driving new trends and new considerations around technology and architectural and managed technical debt. Social and productivity. I'm not going to read all of these, but as you can see, the new IT lifecycle trends are driving additional considerations that weren't previously thought about when it came to managing technical debt. So if you're on that roadmap for modern architectural approaches such as DevOps and microservices and cloud, these are the things where you have to course correct slightly if you do have a framework that you're following for managing unmanaged technical debt, to factor where technical debt could be coming in regards to the new IT lifecycle technology trends that you'll be experiencing as well. The new IT lifecycle, and this was based on some work that Dr. Jeannie Ross at MIT did about 6 or 7 years ago, which is most organizations have sort of moved away from the traditional plan, build, run, and then execute and sort of manage and operate, where with the introduction of cloud and certain cloud designs, whether it's hybrid or public cloud, is really organizations are committing to those platforms. Build and run is still in existence, because obviously you still need to build and run upon those platforms. But this key one around exploitation of the technology investments that you made around the new IT lifecycle is really the factor that isn't being looked at today more holistically and more broadly. So you may have started a journey to cloud, you may be basically adopting scaled agile development practices, and then actually most organizations then are in this sort of junction point where then they don't really have a managed framework to exploit that technology investment. So what ends up happening in organizations, and the last few organizations that I've worked in, is what you tend to see is the runtime costs significantly increasing and the innovation spend decreasing. So that's the first red flag, the first indicator that there is a problem somewhere in the organization, that actually unmanaged technical debt is not being addressed appropriately. Hence me introducing the sort of new IT lifecycle as a concept, if you haven't come across it before, is if you're having runtime costs increasing even though that you're leveraging cloud and microservices and some of the new technology trends in the landscape, if those runtime costs and operational costs are increasing and not decreasing exponentially, then normally it's the first indicator that you have a problem around unmanaged technical debt, because ultimately you should see runtime costs decrease, maintenance spend decrease, and that budget that was allocated to that sort of really move over to the innovation spend, where an organization can then focus on features, products, velocity, and agility to get those in the hands of their customers in a timely and efficient manner. The core domains that we tend to consider when we look at technical debt and unmanaged technical debt are function, structure, and experience, and each one brings its own consideration when we think about technical debt. So again, what I'm really trying to convey here is that it's the ability to break down technical debt into smaller chunks based on whether it's, you know, experience or management or workforce or documentation, whether it's technical or quality, but also one level down, which is, you know, the functions of an architecture, the structure of the architecture in terms of where you may see or not see technical debt, as well as the experience of the consumers of where you've wanted your architecture to get adopted. So again, breaking it down one step further as a framework to manage technical debt just really gives you a method, an approach to really understand and then subsequently manage that unmanaged technical debt as you progress through the architectural life cycles. So as I've mentioned, technical debt isn't new. Ward Cunningham first coined the term technical debt in 1992 as a software design metaphor that highlights the compromises between the short-term tactical gains of getting software out the door and getting the release done on time versus the long-term viability of the software system. And again, whether you're new to this, you know, it's been around 20-25 years in terms of the conversation around technical debt. Even in my 30 years in the IT industry, I have, you know, out of the hundreds and, you know, maybe even to the thousands of organizations that I've worked with and alongside, I've only seen one or two that really have a handle on technical debt. And that 500 billion that I mentioned in the previous slides for an organization that don't do this at the industry at large, I would say that's a fairly conservative estimate in terms of what the cost to a business, what a cost to the efficiencies of getting our customers happy in terms of the software and services that they consume on a day-to-day basis. Just because there isn't a great deal of there's not a great deal of information out there on how to practically manage it, but also there's not a great deal of information out there in terms of being able to break it down into sizable chunks to have those conversations back from an organizational perspective. So it becomes a challenge. Some of you may be familiar with Martin Fowler's work. He's probably the most famous individual when it comes to enterprise architecture or architecture in the enterprise, specifically around some of his repeatable pattern creations. But he did a piece of work a number of years ago, which is where he created this thing called the technical debt quadrant. And it's really again the sort of third consideration here. So we've talked about the key focus is unmanaged technical debt. We've talked about really making sure we capture deviation expense considerations early on in the architectural life cycle. This is the sort of third one, which is really a key point, which is there is deliberate reckless debt, which is we don't have time for design. And again, you tend to, and apologies for any engineers on the call, is engineers are very much focused on you know, features and functions and getting those out the door. And yes, you know, they are doing architecture still, but it's the breadth of architecture in terms of the consequences of where architecture comes in and sort of provides that guardrail is really that balance and the trade-off between reckless, deliberate technical unmanaged technical debt versus inadvertent technical debt, in terms of just an organization may not have the experience, hence the technical debt focus on the experience layer, to understand that it's inadvertent technical debt. So this is a useful quadrant when it comes to planning out the framework to address technical debt within an organization, because what you're really trying to do is to identify early on whether it's reckless or prudent technical debt, whether it's deliberate or inadvertent, and breaking the sort of sections down to capture them in this way helps you really identify where if obviously maintenance and operational spend is increasing, is where to focus the energies, where to focus the resource, and where to ultimately focus the budget to address the unmanaged technical debt within an organization. So it's a useful quadrant, but it is just a tool. It's not going to stop you getting technical debt or unmanaged technical debt, but it will help you to break down and understand and identify those areas that are ultimately causing the biggest concern within the organizations that you work for. Technical debt versus business priorities. This is the trickiest one that we have to deal with. This is always the one that ultimately is the blocker for repayment of unmanaged technical debt is cost. If you're not having these conversations as part of incremental planning, if you're following scaled agile, if you're not having these conversations with business stakeholders that are providing elements of the budget early on, you will just continue to incur unmanaged technical debt. And you may not see it in the first year, you may not see it in the second year, but I almost promise you that by year 5, this unmanaged technical debt, if it's not considered, will come back and add a level of complexity that will cost an organization more, and also basically will ultimately slow down the ability to be agile in the architectural life cycle. So whilst it's good, the short-term gains, and again, I'm not being purist in terms of you won't ever have to incur the deviation expense up front, but it's really about, when we look at those first 3 red flags and those first 3 considerations that I've already called out, it's the sort of business priority is when to repay, which is ultimately the question that you need to get answered. And if the business has agreed not to repay, for a set period as part of the return investment of an architectural life cycle, then that's also acceptable. But ultimately, if you haven't conveyed the message that technical unmanaged debt is causing velocity and safety concerns by introducing new features and functions, then ultimately you'll run into problems later on. And that's where I see most organizations today, is they haven't considered it for 10, 15, 20 years, and they haven't considered, basically because they haven't been able to easily identify where technical debt or unmanaged technical debt resides. So they haven't been able to articulate and have that conversation that has been effective in terms of when to repay, or when should they repay that technical debt to make it more manageable. Communicating technical debt, that ties on to the comments that I've just made. You have to basically communicate technical debt in business language. It has to be cost and risk sort of considered. So when we think about impact and probability, we have to convey it when it comes to what is the impact of doing something or doing nothing, and we have to think about the risk to the business. And the risk should also be fed into, if you're working for a large bank, they'll have tiered risk layers. These are the types of conversation that should be fed into a tier 1 consideration, which is really around the strategic risk that is being introduced by not managing technical debt in an efficient, systematic way within an organization. Because ultimately, the deviation expense that you incur early on, you probably won't see any problems. You'll have people with experience, you'll get it done, the feature will get released. But it actually has a significant impact, like I mentioned, around if operational maintenance spend is increasing, and you're not basically taking those budgets and those funds into the innovation spend area when it comes to exploitation of the technology investments for moving to modern architectures like cloud, then it's normally the strategic debt that has the biggest impact. And again, most people often see it way too late in the architectural life cycle, and at the point where it becomes a strategic blocker or impediment, then what tends to end up happening is it becomes a much more difficult conversation to talk about the cost of remediating the technical debt to actually move the organization forward in an agile way. So again, it's important to think about as point 4, that if you're not regularly communicating technical debt or managed technical debt, if you're not getting visibility of managed or unmanaged technical debt, if it's not part of an architectural life cycle, whether it's a design authority or part of the incremental planning conversations that are happening, you're probably incurring some technical debt without you knowing about it, and it'll be hidden. It's one of those things that in my experience over the 30 years, it's the stealth impact to the technology architecture that doesn't need to be there. I'll be honest with you, it's only the lack of this consideration or the lack of these considerations that is imposing the significant cost and complexity and the ability to address it efficiently. It's got nothing to do with just something that's outside of the control of a technology function within an organization. It's just the lack of a systematic approach to its consideration through the architectural life cycle. Again, doability is important, a return on investment in terms of, are we going to get a return on investment by repaying the technical debt, or do we basically just retire the architecture and go through a new architectural life cycle as we go through each iteration? We have to make decisions, do we repay or defer? But understanding the risk and impact of repaying or defer, that's really clear. I'm yet to see an organization that has provided me when asked for, even as going into new roles with large banks, and I've worked across multiple industries: retail, finance, government, automotive, and I'm yet to see, unless I've been working with them and got them to the point where they do it, is really basically that decision tree that is really clearly articulated to make the decision on to repay or defer based on impact and risk. And then obviously budget is going to be a key one. If you don't tie this back into the budget planning as part of the broad architectural consideration, you will never repay unmanaged technical debt, because the business wants to release new feature. Yes, the CIO is ultimately accountable for risk and safety, but actually, unless you can communicate it effectively and efficiently, you basically will end up in this quagmire of complexity, as many of you have probably experienced, in terms of being able to manage it effectively as you move forward through the life cycle. Let me pause there for a moment, Hazem, just in case there's any questions that have come up. I'm not monitoring the questions window. Let me just give a couple of seconds.
So if there are any questions, please, from the attendees, please feel free to ask it in the question window, and I'll go ahead and ask. But in the meantime, perhaps, Wayne, just on this topic, so I was wondering if you're a CTO or a development manager, and you're taking over a company with massive amounts of technical debt. Let's say they have legacy in place and they're moving to the cloud. What would be your approach?
Yeah, no, that's a great question, and probably 9 times out of 10, specifically for investment companies, or even if you're moving into a role where you're going to have to manage some of this stuff, is really the first point is to understand.
Wayne, I'm sorry to interrupt. It seems my mic was not functional, so people could not hear me. I'll just repeat the question. Yeah, thank you. Thanks for calling that out. My question was, if you're a CTO taking over an organization, a team that possesses a lot of technical debt, let's say you have, going from legacy to the cloud or something like that, what would be your first step, and how would you approach that in an organization that you're new to?
Yeah, no, that's a great question. I think for me is most new CTOs or most organizations are as part of mergers and acquisitions, or basically looking to invest in an organization. The first thing is really just to spend some time in terms of where the technical debt is residing. Is it in the platform? Is it in the documentation? Is it in the experience? What are the causes that we've talked about just up until this point? So really having a good understanding of current state on where that technical debt resides. The second element is the decision-making framework. If you're a new CTO or a new organization looking to invest in an organization, what you want to be able to do is to make sure that moving forward there is a systematic approach to manage technical debt in a systematic way. Because, like I say, because it's a hidden consideration for most organizations, if you're not basically diligent to capture both current state and a framework for the decision making, is ultimately that long-term strategic and managed debt will come back and tend to bite you. So that's what I normally do, either as a head of architecture role or even as a recommended CTO or an organization that's looking to invest or merge as part of those organizational considerations.
Thank you. I have a couple of more questions from the audience. So one is, how do you suggest managing technical debt alongside delivering new features and maintaining existing platforms? So basically the dual. Yeah.
Yeah, no, that's another good question. I think it's similar to the question that you just asked, Hazem, which is, I always say, and you'll understand why I'm saying this, is engineering can strive for perfection, and sometimes they can achieve it in terms of what they do. Architecture can strive for perfection, but they'll never achieve perfection because of the trade-offs that they have to make. And as part of this is understanding what those trade-offs are, as in defer or repay, or understanding where to focus, budget. Some organizations won't even entertain the technical debt conversation, and the reason I mention that is it does take some good communication skills, but also transparency on both parties when it comes to technical debt. Because if you're a new CTO, for example, or a new CIO that wants to get features and products out because they're being measured up on that, is opening up the sort of handbag, so to speak, and showing all the technical debt that you may have incurred may not be something that executives feel comfortable with. If they've inherited it, they're probably more likely to do so. If they're part of the causality of it, then they in my experience tend to not be transparent enough. So again, architecture is really about, without blaming, really just what is current state, what are the considerations, and the final point, which is where sometimes you have to even create a tax for technical debt. So I'll give you an example. If you're working in a product team in a safe environment in scaled agile, and you're doing PI planning, and really the business doesn't want to talk about repayment of technical debt. They want, they've been given a budget for the next fiscal, they've got a burn down rate, they've employed some skilled people, they want to get features and features out the door. It's not impacting safety, and there's no security risk, etc., etc. So they're not going to talk about budget repayment of technical debt. In previous organizations, we've had to levy a sort of a percentage tax that, as part of budget that's given to even a scaled agile team, is that tax implication is there to focus on prioritized debt repayment that may have been incurred in previous sprints or previous incrementals. So again, it is dependent upon the organization, is dependent on when people are in terms of where they've come into role, is dependent on how transparent and how much they want to bring it to the table. But having a consideration approach will help you manage product and feature release, but also manage the unmanaged debt accordingly.
Great. I have actually an interesting question related to this one. So, you can see it's easy to make the case for things that are easily seen, right? Big features. Yep. But we have, one person was asking, well, how do you make the case for boring things, right? Such as securing the data, or the infrastructure that is not a visible feature per se. So how different is that discussion?
Yeah, no, and it's another great question. And I would say technical debt is a conversation, and I'm glad so many people joined the call this morning, which is technical debt is a boring conversation. Nobody wants to talk about technical debt. Nobody wants to talk about debt whatsoever in our personal lives or in our professional lives when it comes to this topic area. What I found works well, and this is sort of stayed true to me personally as I've worked around these topic areas, are specifically elements around impact and risk. Is if you a boring topic area, for example, if you tell an organization they're going to have to spend 100 million because they haven't factored in some software consideration around Java runtime version 6, and it's going to cost them 100 million to do an evergreening program to repay the technical debt because they hadn't forward thought about an example such as Java runtime version 6 and where it sits within an organization, all of a sudden people's ears sort of pop up. So really for me, I found taking the boring elements, conveying them to the business in terms of impact and risk, just really gets people's attention. It gets their attention on the ability to prioritize. It gets their attention in terms of allocating budget to remediate. Because if you can show a business case and the return on investment around some of these more, less than interesting topic areas, if we like to say, that the business doesn't really either understand or care about, then normally you'll get their attention, because ultimately they're going to basically, now you've done the diligence in terms of capturing it, ultimately they're the ones that are making the decision, and ultimately it's their accountability and their accountability for making that decision. So impact and risk tends to be the way that I approach it, which has worked well for me. Okay, I'm going to move forward, and I'll pause again towards the end just because I'm conscious of time in the last 10 minutes. So just some patterns of technical debt to share with you. Schedule pressure actually relates to the question that you just asked, Hazem, which is, that tends to be why technical or unmanaged technical debt grows in an organization. Schedule pressure, getting features out. And again, like I say, if you can convey it in business terms from an impact and risk, an impact and probability perspective, then you can balance the trade-off between schedule pressure and unmanaged technical debt. Duplication is an interesting one that often doesn't get discussed when we talk about technical debt. The duplication effort, as in shadow IT, is a classic example where the enterprise, from an enterprise architectural perspective, isn't joined up. So I'll give an example that I ran into last year, where an organization is doing PI planning, they're doing new features, they've allocated budget, but they hadn't done the upfront work to understand the interdependencies to what it means to other systems, because they've incurred so much technical debt over the years on what that would mean to actually release that from a time safety perspective in release to those product features. So again, what ends up happening is you either end up with tactical deviation expenses, like two people building two barriers instead of the one when we build a road, just because people aren't aligned in terms of that consideration. So it's another red flag. If you see shadow IT and duplication, there's normally an indicator of high technical debt amongst other areas within the architectural life cycles as well. Also patterns, first time right. His first time right is normally a red flag for me that is you're incurring technical debt, because what ends up happening with first time right is you're incurring deviation expense, not considering the architectural runway from a strategic perspective, and you end up in this position where you've just consumed to get features out first time right. So again, it's another indicator in terms of how you manage this, and some of it is conversation. That a lot of organizations that I've seen over the last 3 or 4 years have been very good at driving the culture within the organization, that they should not be driving for perfection. They should not be driving for first time right. This is where the analogy of fail fast, learn quickly comes from. It's not just about experimentation of architectures and software development that we're able to do now in an agile way, but it's also the cultural aspect that says, do not drive for first time right. It's great if you can achieve it, don't get me wrong, but actually that culture where people feel obliged and accountable, and again, that's a good thing, but we have to change that cultural aspect just slightly to really say, look, you can fail if the strategic cost of the technical debt is the right decision based on impact and risk to address in the long term. So that's really what we're trying to do in regards to the statement of first time right is yes, it's great if we could all achieve it. 9 times out of 10, no one ever can, because of the trade-offs you have to make in architecture, which ultimately means it's a red flag if you've got people coming to the table and saying, we delivered things on time and to budget. I see it as part of the boards that I sit on as part of the open group board, where I certify chief architects at OpenCA level 3, is in their packages they normally say, well, we deliver, success was on time and to budget. Well, actually it's not. Let's break that down a little bit. It's more around all of the things that you needed to achieve, including the repayment of a managed technical debt, that makes an architectural life cycle, a project, a sprint successful, and not just on time and to budget. Quality debt is again, I mentioned this in the first few slides, really just to really reiterate what Ken Schwaber said from the Agile 2006 conference. For every dollar of competitive advantage gained by cutting quality, so this is not considering security, reliability, maintainability, usability, testability, all the non-functional requirements, it costs $4 to restore it. And software as an organization and is an organizational asset, and decisions to cut quality must be made by executive management and reflected in financial statements, which again is often overlooked. So because I reported in directly to the CIO of HSBC, these were the types of conversations that you would have to have, which is, asset management as part of software, which is an organizational asset. When we look at governance from an executive perspective, is we really have to basically think about it in architecture. And again, this becomes sort of flag number 5, flag number 6, that if you're not treating it it as such, and you're not considering quality as part of the design decision through the architectural life cycle, again, you're probably doing two things. One is you're putting the governance and the executive at risk because they can't articulate what the cost of the unmanaged technical debt is, and ultimately B, you're going to slow down the ability to do it. So again, this is still as relevant as it is today, and I would probably say, if I look at net present value of money, we could probably increase that $4 from 2006 to probably double to $8 per gain that's actually created within an organization today. We've mentioned a couple of these things already. So indicators of quality debt, complex testing up front. So if you're doing complex testing, then it's normally an indicator of quality debt. Maintenance teams, if you've got a significant red team presence, or you're doing significant quality assurance reviews, normally there's two things happening there. One is you won't ever remove those, but actually a lot of this should be automated. The controls framework for testing, the controls framework for maintenance should be moving to an automated way that is based on impact and risk in terms of caveats to allow exceptions to that automated process. Heavy configuration of software versus customization, so done after the fact, is again another indicator. An unrealized value is, again, if it's 500 billion at the industry at large with technical debt probably doubling that, then I'd hate to think of the amount of exploitation value that's left on the table as organizations go through their architectural life cycle, and should be really part of this framework that I've mentioned, that we've been talking about, as a way to capture what the untapped value is, by not considering repayment or deferring a managed technical debt in a systematic way. So these are just some of the indicators that we often think about. Design debt is another consideration. So the technical features that involve improving the architectural quality attributes that I just mentioned, reliability, usability, security, and the other 27 plus quality attributes of a system. And the challenges faced when not considering them as part of the overall debt management consideration. And you have to go down to that level. There's no point in just picking, which I often see, and what we often see when we're consulting and doing diligence work with organizations, is an organization will talk about security, reliability, and maintainability. While there's 27 other non-functional requirements or abilities that need to be considered, each one with a price tag in regards to cost and unmanaged technical debt. Then if they're not factored in terms of how you do trade-offs in a formal way, and there are methods that we're not going to talk about in this call to do that, then you're ultimately incurring some technical debt as well. Our aim is really to balance the design and design debt. From an innovation perspective, we want to be predictable. We want to ensure that we can predict what technical debt looks like and what it is. We have to sustain the unmanaged debt. Like I've mentioned previously, that debt isn't a bad thing. We wouldn't be able to buy a house if we couldn't, take a mortgage out, if we couldn't incur debt. So debt's not a bad thing. It's only when it becomes unsustainable and unmanageable. And really the capabilities to support that based on some of the topic areas that we've talked about so far in this webinar today. Architectural description, so again, interactions between groups, common languages, coupling in terms of modularity, interdependencies, also become those flags in the framework to really consider, the measure of current state, but also how to address the target state when we think about managing this moving forward. Architecture maintenance is a debt's friend. So corrective maintenance, adaptive maintenance, perfective maintenance, and preventative maintenance. What you're really doing is you've identified the flags in the current stage, you've got consistency of language, you know what you're measuring, you're doing the trade-offs between defer or repay, is really you also then go down to this layer, which is what are the corrective actions that need to take place? How do you adapt skills, capabilities to make sure that this is taking place as you move forward, whether you're consuming cloud or new technology trends? You're really not striving for perfection first time right, but driving for the ability to manage the debt. But ultimately where you're getting to, and this is where techniques such as using predictive analysis based on the data that you capture around technical debt allows you to predict in a PI plan, for example. I worked with some of this with Accenture, and we're doing some of this now in Crosslake, is how do you get to a point where you can not only predict technical debt, but also basically provide the framework and the analytics to prevent it as you consume new modern technical architectures within an organization as well. Debt management.
Oh,
was there a question, Hazem?
Sorry, Wayne, I just wanted to interrupt. There was a couple, I don't know, is that a good time or?
It is. We've got a couple of minutes left. We may run over just by a few minutes, but
Okay.
I can answer the question.
Okay, maybe a couple of quick ones because it's relevant to this. So one quick one on what do you think about reserving, say, 30% of your time for dev resources for addressing technical debt, especially if it's relating to architecture? Is that something common?
I would say time and tax are the two ones. I would say probably 30%, depending on the size of the unmanaged debt. I would say 30% is probably too high. The reason I say it's just slightly high, and I sort of tend to fluctuate around the 10% mark, is because if you end up with 30% of time, and you may need 30% of an individual DevOps team's time to manage it and repay it, is what ends up happening is your architecture will then get blamed for slowing down velocity, because technical debt or unmanaged technical debt is really a velocity killer if it's not managed correctly. The framework that I've been talking about, the systematic approach, should allow you, whether it's tax or percentage of utilization, should be able to do it much more seamlessly, where it's not impacting product or feature release, which ultimately then you don't end up in that situation where architecture is blamed, the business then says you're slowing things down, and then ultimately no one then addresses technical debt. So I would start off low and ramp up as required.
Thanks. Another very quick one, and then we'll get the rest later. But there was a clarification needed. If you have, a component that is an unsupported library or something in your products, not generating any defects, not really impacting quality. Maybe one day it will. Do you count that in as technical debt?
No, if it's based on impact and probability, so if the impact is low and the probability of a vulnerability or a supportability consideration is also low, then you can class that as just inherited technical debt that will be retired at the end of the architectural life cycle. Hence, going back to that conversation, that it's important to capture and measure some of this stuff based on impact and probability around risk from a business perspective. Because if it's low risk and the business has accepted it, you can probably not focus too much attention on that library, etc., etc.
Okay, and we have one more question, but I think you're about to cover it in the slide, so I'll let you take it because.
Okay. So we're going to run a couple of minutes over, but obviously debt management is one of the key areas that we wanted to talk about. Most of the time architectural debt creeps in, as I've mentioned, when the team concentrates on delivery first and sees quality as an afterthought and does not recognize or prioritize elements of both technical and design debt until late in the architectural life cycle. With the emergence of new technology trends, this adds to a level S. It's everything that we just talked about, basically, which is really, if you don't have a systematic approach to managing this stuff, it will just creep in, and it won't be on day one. Like I say, it's normally sort of 3-4 years down the road when you've moved into a new position. This is why, again, it becomes relevant as people change in the gig economy, is it becomes somebody else's problem ultimately, which is not necessarily a good thing for the people that need to inherit fixing some of the technical debt. So how do we manage it? CapEx versus OpEx, architectural governance, measurable benefits, workforce and people. These are just some of the considerations, and all the elements that I've mentioned so far in the webinar is really red flags identification, consistency of language, breaking down technical quality and the other areas of consideration, making sure you're asking the right questions, making sure you're capturing the data as you go through each iteration, basically aligning people, percentage, tax, whatever it is that works best for your organization, then basically gives you at least that stepping stone to start repaying in a systemized way the technical debt considerations that may have been occurred. It is important to analyze the root cause of any particular instance of the technical debt. So plan technical debt. If you're planning it and it's part of the incremental planning, then great. It's managed technical debt. It's not unmanaged. It's not a concern. Delivered technical debt is a concern. So performance efficiency is normally where technical debt has been incurred after the fact, because no one has thought about the quality based on performance ability early on in the architectural life cycle. Discovered technical debt. This is the stuff that's crept in the background and is causing an organization problems, as well as acquired technical debt, which is often in a lot of mergers and acquisitions, that you may be an organization that I worked with one organization, without giving names, that grew by consumption, and it had 1,000. Its parent company was a large advertising company, but it grew by acquiring 1,000 other companies, and it literally was 1,000. The 1,000 other companies that they had acquired were all isolated companies. Now you can imagine trying to understand technical debt and cost efficiencies across that type of environment can add a level of complexity on top of the conversations that we've had today already. So acquired technical debt can often come back and bite you and creep in as well if you don't have a systematic plan in place as you acquire, from a parent company perspective, some of those other organizations. The key one for me is just technical entropy. So feature management is where it tends to creep in more than anything else. So the ability to model this in a systematic way will help you as an organization ultimately get just better exploitation of technology investments organizations are making. These are the sort of areas that are considered. So the business priorities: growth, retaining customers, improving business priorities, and sort of individual priorities when it comes to debt considerations, such as cloud, virtualization, all the things that we've mentioned over the last few minutes specifically. There's really a three-step approach to it, which is evaluate current state, prioritize how you either plan to defer or repay, and what are the cultural aspects, and the sort of how do you feed this into, from an architectural viewpoint, into modern practices such as safe or disciplined agile development, depending on what you're following, and think about it from a strategy and risk planning perspective. So again, the ownership of this often waters down and dilutes the importance of it, and then ultimately nobody takes ownership or accountability for making sure that these things are in place. My view is if there's an enterprise architecture function, it should be enterprise architecture across all portfolio architectures in an organization, working with the PMs and associated solution architects. If there isn't an enterprise architecture function, then it's a mixture of PM, sort of business owners, and the architectural function, whether it's application or solution architecture within an organization. But architecture really needs to have some accountability, because they're the ones that have a broader view of some of the sort of unmanaged technical debt that may be incurring. Again, emphasize quality, workforce planning, and knowledge management. These are just three other areas that often have to be considered. Debt prevention is the final element that we often consider. So much of the technical debt is created during the rush to completion at the end of a development project. Expectations at QA can make up for development schedule slippage, results in code not being properly tested as one example. A rush to finish the committed functional scope results in development shortcuts and a lack of time. So again, when you're looking at applying a systematic approach to managing the technical debt, this is one of those factors from a cultural perspective that you align to say, is 80% of our technical debt happening towards the end, because actually we're creating compliant architectures, but we're not creating fully conformant architectures, which means we've designed something, but we're adding stuff in or leaving stuff out that aren't in conformance with the specification. And again, in organizations that I've worked, I've driven for fully conformant architectures, which is you only deliver as part of your sprint what is asked to be delivered. That way you incur less technical debt, and ultimately over a period of time, it just becomes more manageable. And it's a cultural thing. It's not a technical thing, it's not anything else, just purely a cultural consideration. So that's it from the content of the slide. We're slightly over by 5 minutes. Apologies for those that I've taken 5 additional minutes. Hopefully you found it useful. Are there any more sort of burning questions, Hazem? Again, this will be recorded, so if you do have to jump off, then you can go back to the recording and I'll answer the questions that may have arisen that I haven't answered yet.
Okay, so we're watching the questions window if anyone has any additional questions. Okay. All right.
Okay.
Well, Wayne, thank you very much for a great session, and thank you everyone for taking the time to attend. We really appreciate it, and we look forward for you joining us again in one of our upcoming webinars. Please look out for it. And again, the slides will be downloadable for just the next little bit. And of course, you will get a link to them as well to download as you need, as well as the recording. So thank you very much for taking the time, and we hope that this was a useful session to you and a good use of your time. Many thanks.
Thanks, Hazem. Thanks all.
Yeah, thank you, Wayne.